Okay, we're well underway in the restoration of the Cushman Model C binder engine here, and we've gotten it apart, gotten it cleaned up and disassembled, and we're ready to start putting new parts back in it. We found the cause of the problems, and ready to start getting her back together. Here's the carburetor, and it needs a few parts. Some of them I'll have to make. The float is still available. I've got a couple of floats here. Neither one of them are serviceable, but I've gotten it cleaned up and it's ready to find new parts and get it back together. This engine was suffering from a broken camshaft. The cam lobe is broken in two. Upon disassembly, we found this. We knew there was a problem with it. When we were looking at it, the valve was stuck in it and somebody rotated the engine and broke the cam. So this is the stuck valve. This is the exhaust valve. It's been removed. I put it in the mill and centered it up and actually literally drilled the head off, and then drilled down through the stem from the head end and got it freed enough I could pull it out of the cylinder. So we got that out, and you know, when somebody rotated it, this is the cam shaft here, and the cam is cast iron and it's actually molded onto this shaft. So got that all apart and figured out what all we need there. Found a good used valve and got the seat reamed out. Got the old valve material, the old valve stem material that was left, and all the rust and gunk and everything, and it fits real good now. Here's a view from the top side, and it has been lapped in, and I think our exhaust valve problems are over with for now. Here's the intake valve and how it sets in here in this pocket, and this is all there is to it. It's an atmospheric valve. It sucks open, lets the charge in, and let me stick it here in the plug hole just to hold it there. I'll show you the copper gasket. Had a copper gasket here. Now, I'm sure somewhere in the world these are available. I looked for a short time, went to the local auto parts store. I've seen these in different sizes, but they didn't have anything quite this big. This is about 1 inch and 41/32 on the ID. So I'm going to make one. I've got a piece of copper set up over here in the lathe. Now this is risky business. This may or may not work. We'll see. I've got the four-jaw, got it centered up in there, lightly touching it, and I'm going to go in here and very, very carefully bore the ID to match that valve housing over there, and then I'll probably go on the saw, the bandsaw, and cut the OD. So that's at least the plan for now. I've cut a few gaskets for it. Got those made, the major gaskets. While we're talking about the valve train, here's the valve. There's the camshaft gear. It bolts onto the camshaft. And here is the follower. It's broken. There's the pieces I found in the crankcase. I don't readily have available this piece used, so I'm going to reproduce this piece, and I'm going to actually use a modern engine valve follower, cam follower. I'm going to incorporate that into my new piece. I may shoot some video on that, but I've got to make a new follower here, and the valve adjustment bolt goes in this end. That's the threaded end there. So I've got to make that stuff yet for it. Here is the new used camshaft, and it's even got a casting flaw in it there, but you know, that's not going to affect the use of it. It was running in an engine where there was only, maybe not quite a quarter of an inch running on the cam lobe here, and I can only assume that the lifter in the engine that this come out of, its follower was broken too, because this needs to have a nice wide seat to rub on the full face of the cam, and pictures that I got from the other engine showed all this gone. This part here was all missing, and it was just the diameter of this follower that was running on the cam lobe. So you know, it had its problems too. I don't know if that's a weakness in these engines, this cast iron cam. I know it's fragile. If you've got a stuck valve, you certainly don't want to rotate the engine until you either get the cylinder off of it, or you know, make provisions not to put a lot of pressure on this cam lobe. If you've got one of these engines, be very, very cautious of the camshaft. Okay, here's a shot of the two camshafts. This is of course the broken one. This is the replacement, and if you'll notice, this end, our original, had a longer shaft on it here. The replacement does not have that, so that is going to constitute a change in the way this engine is set up, because the original engine that we're restoring was equipped with a Dixie Magneto. This was an option. This housing, which the Magneto bolts to right here, was an option on the engine, and this extended shaft had this gear that ran in this housing and ran the drive for the Dixie Mag. So we're going to do a Magneto Delete on this engine. We're going to put the donor engine ignition system on, which ran off of this end of the cam, and ran a set of points or a timer mechanism to run a buzz coil, battery buzz coil. We're going to eliminate the Dixie Magneto, which is the next subject. This happens to be a Dixie 601 Magneto, which was a very popular Magneto for this particular engine when it was made available. These Magnetos, however, suffered from some serious problems. If the points housing cover was ever lost or left off, and this was exposed to the weather, this is pot metal, and you can see how it has deteriorated to almost nothing left. This was a housing that clamped over this boss here on the mag, and this holds the points. This is the points cam here. This side of the Magneto is pretty rough. Going to require some extensive manufacturer remaking of some parts if they're not available, and I'm not sure if there's anybody making new parts or what, but since we're doing the Magneto Delete, I think we're going to leave that for somebody else to worry about. The other problem with the pot metal is the base. This base is made out of the same material as this. Luckily, the base was greasy enough and protected enough that it did not suffer any deterioration from the weather, and this base is actually in excellent condition. All the threads are good. The threads are the first to go. The threads are all good. This base looks great. I haven't looked inside the mag yet. This may be a project for another day, but for right now I'm just going to get the engine running. Everything else on the mag looks pretty good, but you know, we're going to do the Magneto Delete and worry about this another day. Goal is right now, you know, just to get the engine running and get it off the bench and get it to making smoke. And as I said, everything I've read on the web about these magnetos is really not a lot of good information. It's good information, but it's not good news that I'm looking for. This impulse mechanism here is actually the best part of the mag. Everybody says that I've read say that they don't have any problem. And when I'm turning the mag, I feel the magnetism in it. I feel it. I think this mag is going to be good if we could get this issue taken care of. And there's a little switch here. You switch this down, and that'll actually catch the impulse and will allow it to impulse. And I'm assuming maybe after it gets running or something, you flip that up so it doesn't impulse anymore. I don't know if that automatically kicks out or what the deal is. I don't know enough about it at this point yet to really say for sure, but I think the mag's okay other than the points holder. So we may make this part available sometime if someone needs to put a mag on.